Okay, you see here, see now here, I'm having a motor here, okay?
Mm.
Now I'm having one more here, a variable frequency drive and a motor here, okay? Now here, let's say I have one transformer here, a EV transformer. Let's say this is a 433-volt system, okay? Here. Now here, let's say I have a UPS here, okay? Now, see, when any harmonics is generated by non-linear load, so this will generate a harmonics. Harmonic current will flow from the load to source. See the difference. Our source current will flow in which direction? Source current will flow like this, and harmonic current will flow in the reverse direction. It will flow from here. Now here also there is a harmonic generation. See in this single line diagram, two items are generating the harmonics here. One is my VFD and one is my UPS here. But remember one thing, my transformer here is star, my transformer here is delta. Whenever there is a delta winding, okay, when I say the harmonics, see the rectifier. If you go to any power electronic circuit, we have what is called as bridge, right? This is my AC and this is my DC, right? Now what is happening here? This is the AC side, okay? Now here, what you have to see, my power current is flowing in this direction, and my harmonic current will flow in this direction. Okay, this is a six pulse rectifier. Any whether it is a variable frequency drive, whether it is UPS, all of these they are having a rectifier inside. That rectifier is the one which generates the harmonics. Here, the harmonic generated by this fellow is fifth pulse and seventh. Fifth and seventh harmonic is generated here. Okay. Now, this harmonic current will not flow if there is a delta winding here. If it is a third harmonic, other harmonics they will flow. Now, what happened when there is harmonic? All these harmonics, no, they will flow here. Why I am bothered about third harmonic is, see here if I am having my NGR, see other harmonics, see here this is a maybe 12 pulse rectifier may be there, or 24 pulse. If it is 12, the harmonic may be 11th and 13th. 11th means 11 into 50 hertz. 13 means 13 into 50 hertz. These harmonics may be there here. These harmonic will not be a problem for NGR because these harmonics they don't enter the neutral. All three current are in phase, whereas the third harmonic is the only one which actually will get into the neutral. Okay. Here, since there is a delta winding here, third harmonic will not come. There is no contribution of third harmonic from this system. Okay, but there will be third harmonic from this system. So that third harmonic, see there are two even, there is no even harmonics, there is only odd harmonics. Small amount of third harmonic current will come from here and that will enter this neutral. Okay, and since see NGR is a device which will conduct current only when there is a fault. Whereas a third harmonic current is a continuous current, it is always present. Because third harmonic is a continuous current always present, it will cause small amount of heating. So whenever you have variable frequency drive, okay, please take care of your NGR design. You please find out from the VFD. What you have to find out? How much third harmonic current the VFD generates.
That will be there in the data sheet, is it, sir?
Yes, it will be in the data sheet. If it is not in the data sheet, you get the data and you give it to the NGR vendor, because NGR vendor has to take care during his design. Okay. This is one source of third harmonic. There is one more source of third harmonic, and that I will tell you. If you are having a generator, no, when I'm having a number of generator in parallel, see the generator design, both of them are not fully identical. Because both generator design are not identical, what will happen? The pitch, winding, all those the variation will be there. Because of that, there will be a circulating current, and that circulating current is nothing but it is also a third harmonic. If you have your this one NGR here, what happens? That circulating current will flow like this. It will flow like this. So your NGR will get heated. Okay. So whenever you have generators in parallel, that time also you have to inform your engineer vendor. So whenever you have VFD or whenever you have generators in parallel, you inform the NGR vendor about the scheme, so that he will design your NGR in such a way that it will not get overheated. Okay. Now, see third harmonic, I have told you one of the cause is the variable frequency drive. The another main cause is because in a generator, see generator actually if you see the flux generated inside a generator is not fully sinusoidal, because we have made it sinusoidal by our winding design, but it is not fully sinusoidal. So it is a non-sinusoidal flux. Okay. Now, because of this non-sinusoidal flux, what will happen? There will be small amount of harmonic generated by the generator also. Now, when you connect two generator in parallel, that time this becomes more. This problem becomes more. What will happen? There will be a circulating current within the two generator, and that current will flow through your neutral. Okay. Is this clear?
Yes, sir. Sir, I have one question.
Yeah.
See, we are saying that now the NGR does not carry a continuous current because it will only act when there is a fault. But in this 30th, how is it possible that we can have a continuous harmonic current in the NGR? Because ultimately it works only if there's a fault. So how is it that the harmonic current will actually be flowing through this? I
See,
didn't understand that.
see, see, AGR will carry current only when there is a fault, right?
Okay. Yes, sir.
Now, third harmonic current is generated by not by a fault. Third harmonic current is generated because of the
Non-sinusoidal flux.
it is a generator which is generating third harmonics.
Okay, sir.
Okay, and
Yeah.
generator is generating this continuously.
Okay.
As long as it is generating power, it is generating third harmonics also.
Okay.
And third harmonic current, see your phase current. See, okay, hold on. Let me explain you this one. See, this is phase A, right?
Yes, sir.
Then let's say this is phase B.
Okay, sir.
Let's say this is phase C. Now each of these phase will have its own third harmonic current. Okay,
Okay, sir.
so it will be something like this. Okay,
Okay.
now you see the third harmonic of this current, and then see the third harmonic of this current. So what is happening, you will observe here. See, the IR, IY, IB are, see, the IR, IY, IB are all 120-degree out of phase. Okay.
Okay, sir.
Whereas the third harmonics, all of them, they will be in phase. They are never out of phase because they are three times. If you draw this by, if you looking at this, no, you can make out the third harmonic is always in phase. Since all three current are in phase, what happens when I add
Lambda.
IR plus IY plus IB, balance current, it will be zero. Okay. Whereas in case of third harmonic, if it is a third harmonic, no, IR plus IY plus IB will be three times. Okay. So third
Okay, sir.
harmonic current will not cancel in the neutral, it will get added up.
Okay, sir.
What I'm trying to tell is generator will generate all sort of harmonics, not just three. It will generate three, five, all generator will generate this. See, the voltage given by a generator is not purely sinusoidal. See, this is a
Okay, sir. See, my
just
query.
1 second. I'll just
Yeah, sorry.
this is a pure sinusoidal voltage. Okay,
Okay, sir.
so it is made of only 50 hertz component. Now, if my if if my wave is something like this, no, then it is made of 50 hertz component, 150 hertz component, 250 hertz component, so on. Many harmonics are there. Generator is not an ideal generator, it generates harmonics. The all other harmonics, there is no problem. Whereas this third harmonic, no, it gets added up in the neutral. All
Okay, sir.
triplet, we say triplet harmonics. Triplet harmonics means what? Third harmonic, sixth harmonic, ninth harmonic, 12th harmonic. All these are called triplet harmonics. All these get added up in the neutral, and that will cause heating of the NGR. And that is a continuous process. Okay?
Sir, my query comes is, see, I can understand that these harmonics are flowing in the neutral.
Yeah.
My query comes is, why is it flowing into the NGR? See, the NGR is connecting to the earth. My doubt comes is, I can understand that harmonic is flowing through the neutral. It is heating up the neutral.
Yeah.
Why would it flow into the NGR? If it flows into the NGR, it means it is going into the earth. So somewhere it has to complete a circuit. How it will complete circuit if it is going through the NGR, sir?
See, from your phase, see the harmonic current no, was flowing into your phase winding track. Okay,
Okay, sir.
it is going to the phase winding. On all phase winding are connected in a star, right?
Okay, right.
And the star point is connected to the neutral.
Yes, sir. The star point is the neutral.
Yeah,
The star
neutral
point.
and neutral is connected to NGR
Yes.
and NGR is connected to the ground.
Yes.
So now, see here, see the for answer to your question is if I am not paralleling my generator,
Okay.
then there is no problem.
Okay.
If I'm paralleling two generator, then from my NGR it goes to ground. From my ground it will go to the NGR of the second generator.
Okay. Understood, sir. Understood. No. Very clear.
Understood, no?
Yeah. Very clear. No.
So basically it is this is the thing. Okay.
Okay, sir.
So now I will give a small exercise. Please do that. I will do right now. I will take 3 MVA generator. Okay,
Okay.
6.6 kV. And I have a motor here 400 kilowatt. Okay, you please determine the NGR rating. Okay, that's all. No,
Okay.
Both there are two generators, sir. 3 MVA 6.6.
ಎಷ್ಟು ಓಕೆ ಸರ್ ಸರಿ 645ಗೆ ತನ್ನಿ 645ಗೆ ತನ್ನಿ ಆಯ್ತಾ ಓಕೆ ಥ್ಯಾಂಕ್ ಯು
you're able to understand.
ಕಾರ್ಡ್ ಓಕೆ ಥ್ಯಾಂಕ್ ಯು
Are you able to understand? Any doubt on this?
ನೋ ಸರ್ ಜಸ್ಟ್ ವರ್ಕಿಂಗ್ ಇಟ್ ಔಟ್ ಸರ್ ಒನ್ ಸೆಕೆಂಡ್ ಸರ್
You can mute yourself, Mr. Pinaki Sharma. Yeah, yeah.
Sir, what is the approximate fault of that 3 MVA generator? Can you give us that or something we have to work out?
3 MVA generator, how much? Let's say, let me take the XP double dash as, let's say, around 10%. If I
10%.
take 10%, the fault current will be 2.5 kA.
Okay, sir.
So this is 2.5, this is 2.5, this will be around 5 kA. Now here, see, since I don't know exactly, see, if actually
We need to have some assumptions, sir.
if
Otherwise,
you don't know the cable size, let's say this is 95 square cable, you can actually do this later on. You take it as exercise because I think you cannot do right now. Take this as 95 square take it around 400 meters, okay? And you determine what is the fault here at this point, okay? So the fault takes place here, and then fault takes place here. You find out what is IF1, you find out what is IF2, then you find out what is the ratio of IF1 by IF2, okay? Once you get that value, now since this is 255, what will be the CT rating? CT will be 250 bar 1 amp CT, right?
it's about 300, sir. 300 bar
300
1.
bar 1.
250 bar 1 amp CT, it has to be a 250 bar 1 amp CT, right?
So
300,
the
sir.
full load current is 262, so 300 bar 1.
262.
Yeah.
Pardon?
Full load current is 262, so CT rating should be about 300 bar 1, sir.
Okay, okay.
Sir, what I thought was if it is 300 bar 1, now then in that case, 10% sensitivity if we take the maximum, the minimum that it should take is 30 amps. Will that thumb rule not work, sir?
No, you are correct. The minimum is 30 amps, fine. But if you put a NGR of 30, see the lowest is 30 amps. Like in the previous case, I can say my NGR minimum has to be 45 amps, I can say.
Yes.
That will become too low.
Okay, okay.
See, if I put a 30 amps NGR, if I put 30 amps here NGR, then what will happen for a fault here? It may become 10 amps. Then my relay will not pick up. I cannot put 30 amps NGR. 30,
Sir, one question. Now, if it is 10 amps at the motor end,
yeah.
yeah, correct. Yeah, correct, sir.
I cannot put 30 amps NGR. It will become too less. I
Okay,
cannot
yes,
go
yes.
for
We
10%.
need to know we need to know what is the fault level to be restricted at the motor.
Yes.
If we know that, then we can work it out, sir.
No. You do
Yes.
one thing. You please later on, not now. Later on, you do the calculation. You find out what is IF2. Okay, I've given you cable size is 95 square motor length is 400. You please determine what is IF2. Okay, you know IF1, you know IF2. So let's say IF1 is, let's say, 2.5 kA.
Approximately 150 ohms, sir. It will be, no?
Okay, so let us say IF2 was, let us say, around 500.
1 kilo ohm. One IF2 would be approximately, I'm getting, just taking proportions, I'm getting about 0.8 kiloamperes.
Okay,
So
you are
roughly
getting
you can
0.8
take it.
kiloamps. Okay,
Yeah, so that I'm taking roughly as 1 kiloampere.
okay. Let's say 0.8 kiloamps. So it is approximately 3 times, right? So
3 times.
current is reducing by 3 times.
Yeah, but I have two sources, sir. But I have two IF1s.
Okay, we will get to that. Since the fault
Yeah.
rate is reducing by 3 times, so 25 amps. So I have to get how much? A fault here,
Yeah,
IF2 should be at least, if there's a
90 amperes. 90 amperes, no?
if there's a fault here, I will have the contribution from both, right?
Yes, sir.
So
Then it is 5 kiloamperes divided by 0.8. Approximately it is 5 times. So that will be 5 times 30, about 150 amperes you get, no, sir?
See,
I'm
if
thinking.
if this breaker failed to trip, no, then
Yes, sir.
both of this will trip.
Yes.
Yeah,
For both of these to trip, both of them should see 25 amps. For both of
Yeah.
them to see 25 amps,
yeah,
so how much? It has to be at least 50 amps here.
yeah,
If it has to be 50 amps here, my NGR here has to be 150 amps,
yeah, that's what.
right?
Yes, sir. Both NGRs will be 150 150 ohms. So,
150
but then because you have
150
two.
amps. See what I'm telling. If I have to get 25 amps from here, I have to get 25 from here. So
Yes, sir.
both I will get 50.
Yeah,
Okay, this need not be 150. This can be 75.
75, because it will each will contribute half and half. 75 ohm, 75 ohm.
So when there is a paralleling, the slightly
Yeah,
there is a difference. So
yeah,
it can be 75, but when they
yeah.
design, no, they will
Yes,
take something like 100 amps or something much higher. Okay.
yeah,
And
yeah.
since both the generators are in parallel, there is a continuous flow of the third harmonic current. Because the continuous flow of third harmonic current here, the vendor will do the design in such a way that the heat generated during normal this one, will not damage the windings of the NGR. Okay. So this calculation I want you to do later today. Or I think you need not do this calculation. Okay, you have already understood it. So the concept you have understood, no?
Concept you understood, sir, but some more examples and some, if you have some SLD with one
My
steps, if you have,
my
sir, it will be very
suggestion,
good, sir.
you take any example or anything, you post it in that one, this one. Then I will clarify. Okay. If you have any example or any this one, you can post it. Any doubt or any calculation if you want to do, you can do and you can post and then I can guide on that.
Okay, sir, if you have some steps, logical steps to working out also, it would be good, sir. This is very rough what we have done.
See, logical steps means.
Like just one typical, as you said, sir, some example you have.
No,
Otherwise,
example. I have shown two examples here. No, these are
okay, sir.
these two SLDs are the examples I have given. If you want to, ask some other typical SLD you are having, you want to ask, you can ask me that one, no problem. That is what I am telling. Okay. Now, see, tomorrow I will cover this specification of NGR and NGT. See, one more thing I want to tell you. Now, when we specify the NGR, NGT, we are giving the current. The resistance value, the vendor is doing the calculation. Okay. I'm not getting into the resistance value. You might ask me why you didn't specify ohms.
Then we will only tell the fault level to which it has to be restricted to, or what do we give exactly, sir?
See, that is where tomorrow I will explain about the specification of this NGR. Okay, I will explain to you tomorrow on the specification of NGR, construction, ingress protection. Then I will also explain about the NGR material. Then I'll explain about the temperature coefficient of NGR. Okay, then I will explain about NGR failure, that in the afternoon, tomorrow evening. Then monitoring of NGR. Okay, those things I will explain. And so tomorrow mainly we will talk about NGR, this one, the specification. Okay, we will go more deep into the specification part of the NGR tomorrow. Now, any doubts on
Sir,
what we discussed?
one question, sir.
Yeah, please.
Now, suppose a medium voltage motor is on a fuse and a contactor.
fuse
in,
and a contactor. Okay.
and in that case, is it how will I know the ground fault setting for that?
See, when you
Because
normally when you are using a fuse and a contactor, the fuse, the earth fault relay fuse will not open for the earth fault current,
yes, sir.
and since the earth fault current is when very less, earth fault current is in the order of ampere,
Yes.
my contactor can be tripped, no problem. Okay.
But what will sense that, sir? Overload relay is only there.
No. See, when you are having a fuse with a contactor,
Okay.
that time also CT will be there. CT is always there.
Yes.
In that feeder, if you are having any typical schematic, you please check it. You can go and check now.
Okay.
Fuse with contactor feeder will also have a CT, will also have a relay.
Okay. That will
Though
trip
there is a
the.
fuse, though there is a fuse, that also will have a relay. And the earth fault, there the phase fault is of no significance. 51 is of no significance because fuse is there. But the 51 and the earth fault relay, that will trip the contactor.
Okay.
Okay. If you are
Sir, can you go back?
pardon, yeah, tell me.
Sir, can you go back to that schematic which you very first showed us where you solved one problem, sir? This one, sir. The next one, sir. Yeah, this one. See, I just wanted to ask one thing. See, now here you are identifying the fault which is the lowest, and then you are sizing the NGR. Am I right?
Yeah.
So now what I understand is that, see, you have 45 ampere, 450 amperes here. You have 2.25 kVA here, 6.3. So it is one third. So one third of that. So you're saying one third of that is 45 amps. So in this particular case, sir, in this particular case, your resistance would be 150 ampere, 150 ohms. Am I right?
No, are you talking about ohms or amps?
Ohms. The NGR resistance would be
No,
150
I'm
ohms,
not
am I
talking
right?
ohms. See, the first thing is I am not talking about ohms at all. I'm talking only in amps.
Okay. Let me understand this. Just for this example, I am restricting my 2.25 K at the at IF5. Okay. Now IF5 is one third of 6.3.
Yeah,
Because it is one third of that, then the current should be the NGR rating should be such that it should allow three times the rating of that at the 51 end. So if I can take 45 amperes as 50 amperes approximately,
yeah.
it should be minimum 45 amperes and maximum it should go up to 150 amperes. Am I right?
Not maximum. It is minimum. Minimum rating of the NGR has to be 150 amps. I can take either a 150 amps NGR or
Yeah, 150.
300 or 250 or 300. My NGR
Okay.
rating should not be below 150.
Not be below 150. Okay, sir. But the thing is, suppose now I rate it to 150. Okay.
Yeah.
Under what condition will I ever have a fault which is more than 150 amperes, sir?
If you have put a NGR
Yeah.
of
So,
and you are restricting it to, let's say, instead of 150, let's say I restrict to 200 amps,
yeah.
and my fault current will not go above 200 amps at any cost.
Right. It will not because I've calculated for the lowest, as we're saying, the lowest fault in the system.
Yeah, see, only thing is what happened, the motor, each of this motor also will contribute 6 times its own current, and due to that, fault current will increase. Okay, but that will not have any impact on the 51N upstream.
Yeah.
Okay, the
Natural.
upstream
Yeah.
contribution will not increase beyond the NGR rating.
Right. So what I'm saying is that let's say just in this particular example, I'm taking one third of this and I'm taking 3 times 45 amperes or 3 times 50. So I make it a 150 amp. I'm restricting it, saying that it will not go over 150 amperes.
Yeah.
The NVR. So now the ohms you're saying is determined by the vendor. Am I right, sir?
Yes, yes.
Yes, no, sir. And so the ohms is determined by the vendor. Then, but in the next calculation that we did, we worked out 150 ohms. No, sir. That was
No. We didn't calculate any ohms.
no that
Ohms
one
at
typical
ampere.
that 6.6 kV we did. That was 150 ohms only. What we did on that scratch calculation, no, sir.
No, that was not ohms. That was amps only.
Ohms
Ampere.
only. Okay, fine. So then, sir, 150 ohms means it will not go above
I'm not
150.
talking
It will,
about. No.
sorry, 150 amperes. 150 amperes.
Amps,
Beg your
not
pardon.
ohms. Yeah.
Sorry, 150 amperes. It will be restricted to 150 amperes. So that if 150 amperes flows in my neutral, that means if it flows in my neutral, so 150 by 150, 10% of that, 15 amperes, if it goes into my 51N, it is detected as a earth fault. Correct, no, sir?
Yes. If the current is above 10%, it will be detected as a earth fault.
Above that, below that, it will not detect it. That means.
See, that's what I want my relay to be functional. That is why NGR design has to be coordinated with relay and safety also.
Okay. So up to means let's say my the NGR current is going at 140 amperes. It will not detect it as a earth fault. That means
It is.
even if I have 150 ampere NGR and 140 amperes goes through it, it will not detect it as a earth fault. No, sir.
It will not detect because it is below the sensitivity of your relay.
Okay, sir. Okay, fine. Okay, sir.
So I hope it is clear. So what we do for today, I think we will stop here. Any doubts are there? Please go through. Okay. Any doubts are there? You please ask me tomorrow morning. We will start tomorrow with the this one clarification. Okay.
Okay, sir.
Okay.
Yeah, and if you're having one more thing, if you're having any single line diagram feeding a motor or something, and you can then take a snapshot of that, I can explain you about that. Or any motor 3.3 kV, 6.6 kV motor. If you're having vendor drawing with schematic, then we can see that there is a relay there with 51N. If you're having, we can check those things. Okay.
Okay, sir.
Okay.
Okay, sir.
So thank you for today's session.
Yeah.
Okay, sir.